Section 2-2, Part 1. You can use algebra tiles to model equations with integer coefficients and variables on both sides of the equation. Use algebra tiles to solve the equation. Notice I have an equation of 6x minus 9 equals to 4x plus 3. I have an equal sign in the middle. This time I have an x on the left and an x on the right. So we're going to use algebra tiles to model this equation. To model positive 6x, notice that we have 6 green x's that model positive 6x. We have 9 red negative 1s that represents negative 9. I have my line that represents the equal sign. I have 4 green x's to represent 4x. And then I have 3 black ones representing positive 3. Positives are represented with black, negatives are represented with red. The first step in solving this problem is to subtract 4x from both sides. If you have x's on both sides, subtract the one on the right. So the first thing they're going to do is subtract 4 from both sides. Notice they remove these 4 green ones, leaving just the positive 3. If you subtract 4 green ones from the left side, you only leave 2 x's. So after subtracting 4x from both sides, we now have 2x minus 9 equals to positive 3. To isolate the variables, we need to remove subtracting 9, so we need to add 9 to both sides. You see here we added 9 black positive 1s and adding 9 also on the right hand side. So the negative 9 positive 9s would cancel, leaving only the 2x equals 2. When you add all 3 positive and all 9 positives, you get a total of 12 positives. Next, it says divide the tiles into 2 equal parts. These 2 are equal, and then separating the 12 into 2 equal parts of 6. Then it says remove one group from each side. If you remove one group from each side, you end up having 1x equals to 6. 6 black. So your final answer would be x equals to 6. Now that's how we would show the representation of modeling this problem using algebra tiles. Now I'm going to solve this problem without using algebra tiles. I see that I have variables on both sides. I'm going to move the variable term from the right hand side by subtracting 4x from both sides. Line up your x term on the left side under the other x term, because you can only subtract an x term from another x term, like terms. 6x minus 4x gives you 2x minus 9 equals 2. The 4x's cancel, 3. Next, let's add 9 to both sides. You're isolating the variable. You want to get the variable by itself. The 9's cancel. We end up with 2x equals 2. 3 plus 9 gives you 12. Next, divide both sides by 2. So x is equal to 6. The same answer that I got when I used the algebra tiles. Let's check this answer. To check, you will take the original problem and you will substitute in the answer that you got, which was x equals to 6. You will substitute in 6 in for both of these x's. So you'll have 6 times 6 minus 9. Does that equal to 4 times 6 plus 3? If the left side equals the right side, then you know your answer is correct. Well, 6 times 6 is 36. Minus 9 gives you 27. And working on the right-hand side, 4 times 6 is 24, plus 3 is also 27. So when the left side equals the right side, you know that your answer is correct. So your final answer is x equals to 6.